If you so let's say the ball was 2.2 seconds.
Yeah.
You'd use that formula to calculate how high it went.
Really? Oh, you could calculate that.
Yes.
With that formula, right there.
Right there.
Holy mackerel! This you throwing the ball?
Of me throwing the ball.
What are you doing here? Spin.
The science of spin.
Is this like centrifugal force stuff?
No, it's mostly just with the pendulum. What it is I was trying to find out that if I were to spin the ball, the weight, the string of a pendulum, would that affect its swing in any way?
Oh, this is like a gyroscope or something? Maybe? Ah, does the spin affect it?
Yes. My conclusions were I did a trial run with no spins whatsoever.
Yeah.
And
that's what these graphs are?
Yeah, and it went just as I expected. It went straight from the 360 to 180, then back to 360.
Really?
Yeah. Then I spun the ball 50 times, and it was a bit more different. Sometimes it would go from 360 to 160 or 150, then back to.
And then you wrote all this stuff down, huh?
Yeah. And my last one, I spun the ball.
Did you draw these graphs, or your computer draw those graphs?
These two, I did on my computer. This one I had to do myself because the ball went a bit weird. Like what would happen is for the last one, I spun my ball 100 times. And what would happen is it would swing from one direction, then it would kind of.
Oh, I see.
So it was kind of hard to.
Like a figure eight.
Yeah.
Because of that spin.
Yeah. So that was a bit hard to draw the graph.
Well, I actually really like math, and when we found science buddies, I looked in the math section, and I really like this project.
Yeah. Things like that are neat. Are you familiar with the golden section, another principle of?
Yeah, I've heard of that quite a lot.
It's supposed to be a proportioning system, also.
Yes,
yeah.
yes, and it's like, in a way.
I did electrical stuff.
You like the what?
Like I made a pickup for it.
Oh, I see it in there. I see it. So let me see that. That's a pickup in there, huh?
Yes. So this is an amplifier cord. So I can plug it in there.
Really? What are you gonna plug it? You got anything to plug it into?
No.
Just a picture.
Yeah.
Well, that's all right.
That's pretty much that little thing right there. That's pretty much how it looks like inside. And that little part's that part.
So you're able to turn a acoustical guitar into an electric guitar.
Yep.
Wow.
Out of like $30.
$30, huh?
Thank you for the applause.
Yeah, he's good at that, isn't he? Yeah. Can you play that thing?
It just went out. I just dropped it and it went out of tune.
Huh?
So it sounds way better now.
Oh, I see.
I just dropped it.
Out of tune? Who's out of tune? Is it the guitar out of tune or you?
Both.
Ah!
Rubber bands for energy.
Rubber band. Rubber band has energy? Really? Where would a rubber band get any energy from? Cornflakes or Wheaties or what?
I was trying to prove that as you held back a rubber band, it held potential energy.
Really?
And as it was moving, it contained kinetic energy.
Oh, kinetic energy. Is that legal? Kinetic energy? Oh, I think so. Well, that is pretty clever here. What's how does this work?
This is there.
Oh, that's your bottled water.
Okay, so the gray line represents the 2030 population, and the red line represents the 2010 population.
Population. Wow. Well, things are booming, huh?
Yeah.
Where are all these people coming from? I don't know.
It's scientific.
What is going on here?
You'll catch on something.
Is this an explosion or what?
Yes.
Where are we going to put all these people when they grow up?
I have no idea.
No, what? Now you're our hope for the future. Well, what are we going to do when all these people grow up? Who's going to feed them? I'm not going to feed them. I can't even feed my grandson.
They will feed you.
Oh no!
All right, thank you.
Tell me what you got here. Talking semicircles.
An arbolos. And
A what?
An arbolos. That's the gray figure right here.
Oh.
See, this says, it really means shoemaker's knife in Greek.
And what would you do with something like that?
Well, my project was, is this circle right here equal to the arbolos?
Ah,
And
is
so
it?
It actually is. My hypothesis
Really?
was correct in that it is. And
Oh, and you
this
proved
circle's
that by
always
what?
this is
Hey, so that's how Pythagoras wrote that, didn't
yes,
he?
he did. And so I actually found ways to solve it online. Then I solved it.
Uh-huh.
And then I actually changed the ways a little bit. And then
You
I
changed
wrote proof.
Pythagoras' theorem?
No, I changed the way of solving it.
Oh, I see.
The way that website had it. And so I wrote a 2-column proofs for it, which means 2-column proofs.
Yeah?
So that means that it tells exactly why that can be done.
Because you have two proofs.
Yeah, I have one here and one here.
Ah, I see.
And it's quite
So this is what you call beyond a shadow of a doubt.
Mm-hmm.
Right. Well, that's
Yes.
good. Well, if you can prove it two ways, you'll find out in what? The geometry or
It's
something?
geometry.
That you have to have proof.
Yes, and it's important because it can use to teach a lot of theories, the Pythagorean theorem. Also one where you have a squared plus b squared plus 2ab.
2AB.
That's the one where you have, if you have a plus b in parentheses squared.
Uh-huh.
And it's important because it can be used in, it's used for teaching. It was used in Japanese temple architecture and a lot in Gothic arcs. You'll notice it's Gothic arcs. And it's used in ball bearings and a lot of mechanics.
Oh.
Because of Steiner's chain.
Well, there's a
That came
practical
from this.
practical application, huh?
And also a lot in landscaping too.
Elaine?
Yes, and since it's
So there's actually a practical application for all this.
oh yes, there is.
Really?
And so many theories came off of that theory. This one theory.
I mean, Pythagoras'
Yeah, well, actually not Pythagoras. This one was solved by Archimedes. This circle is equal to this. It's solved by Archimedes.
Archimedes.
Yes.
Oh.
And so many things came off of that, and you can use it since it's pure math. It can be used in almost anything.
Boy. Did you get Newton in there somewhere?
No, I did not believe. No,
Newton
didn't do
hadn't
this
gone.
stuff.
Okay.
He did a lot with gravity and the way the planets move.
Ah. Well, that's pretty slick. When are you going to hit this ball? When are you going to hit the ball? No, you're not going to hit the ball. I mean, guys, we need to get a home run here or something. Yeah. I heard a rumor that you were just over here playing games. Is that right?
Yeah,
Just tic-tac-toe and all those things. Is that true? What is this anyway?
This is I create a program that lets you play tic-tac-toe against a computer.
Really?
Yeah. And what I did was I used JavaScript
JavaScript.
to write a program
Yeah?
that would let you do this. And what I did was, as you can see here, I wrote a bunch of if statements, like if someone went here, the computer needs to go here.
Oh.
And so I just did a series of those for each move.
Yeah.
And I basically just created a program that does that.
So can you beat the computer?
Yes, you can beat the computer, but the most often outcome is that it's a tie. And then the computer wins, and then.
Ah, so you don't win too often, huh?
Well, I mean, I intended it so that the computer never loses.
Yeah.
But
that's no fun.
Yeah, so I made a couple of possibilities, like where you can trick the computer into like the 2-win situation.
So are you saying you're smarter than the computer?
Well, yeah, because I basically had to tell it what to do. Because the computer can't
That's kind of like your mom and pop, huh? You didn't seem too enthusiastic about that. Well, they're pretty smart, aren't they?
Yeah.
Real smart. Yeah. Well, your computer program is pretty slick. Pretty slick.
Thank you.
Could that be?
It is the seed of germination. It helps. I was seeing if seed germination will affect on harmful or helpful from hydrogen peroxide.
Really?
Yeah, and as you can see, 9 millimeters high. The hydrogen peroxide helps the seed germination. And without going to stores and buying a lot of fertilizer seeds, just get hydrogen peroxide and it'll help the seeds go faster.
That's pretty slick. How'd you figure that out?
Well, I've been doing a lot of experimenting and a lot of researching, and I've just got the results.
Yeah?
And it came like that.
Well, that's pretty slick. Boy, I tell you, I wish I could figure stuff out like that. How'd you get so smart?
We do a lot of schoolwork.
Oh! You must pay attention in class. Oh, I never did that.
So you're going to go